so I'm just going to draw. Have you learned about the wedges and dashes?
Kind of.
So if I draw these wedges like that, it means these methyl groups are sticking out of the board at us. And then if I draw this guy here, that means this one's sticking out, this one's going back. So a cis is saying that they are both on the same plane. A cis is they're both sticking out or they're both going back. A trans means one's coming out at you, one's going back. So if I were to name this, I would probably call this a cis 1,3 dimethyl cyclohexane. Whereas this one would be a trans 1,3 dimethyl cyclohexane. Yeah, so what she's saying there, see if I can draw this so you can see it better, is the fact that you have this guy coming here, and so your X is carbon number 1, and so carbon 3, whether you go 1, 2, 3, or whether you go 1, 2, 3, there you have this 1,3 diaxial steric hindrance.
Oh, yeah.
Sorry to interrupt.
Fine. So rude.
I have to go science.
So it's like Benson. Like you go up to Benson and then you go past.
So that's all it's saying, just the fact that there's kind of drawing how they would hit each other, or there would be that steric hindrance there. And so what she's saying there in your notes is the fact that then if you flipped it, now all of a sudden our X molecule is in the equatorial position, and so there's no steric hindrance there. So a lot of questions you'll probably get is saying, okay, like if we have these two guys here, like which of these conformations is more stable? And so the way you could do this is you draw your chair conformation, and we're going to just say, okay, let's pick this carbon up here to be carbon number 1. So we just completely pick which one we're going to call carbon number 1. And we're going to say, okay, this is going to be our carbon number 1. And so what this is saying is, if it's cis, it means they're either both up or they're both down. So we're going to say that this methyl group is in the equatorial, because equatorial is more stable. So we're just going to say, okay, this one's in the equatorial. So we're going to call it it's down, because there's a hydrogen that would go up here and be in the up position. Like a lot of your notes here is referring to how up and down doesn't change. So being up is totally how you look at it. So this hydrogen is up, this methyl is down. So this is like, this hydrogen here is in the up axial, and this methyl is down equatorial. And then what we do is we say, okay, if we're going to say this methyl is down, because they're cis, this one must also be down.
Because they're cis, okay, yeah.
Where if this is down, then this must be up here in trans.
So you're just like picking one to be down?
Yeah, just because, I mean, nature doesn't care. Like, you can rotate this however you want, as long as they're either both, as long as they're up they're both supposed to be up, or they're both supposed to be down, or if they're supposed to be opposite of each other. So if we say this methyl, we're going to say is down, then we also have to say that this one's down. And so when we come here to this, we know that this 3 carbons or 2 carbons away, carbon 2, 3, you know, we have an up is axial, but we're going to say it's down, so it's going to be in the equatorial position for this cis. Whereas for our trans, if we're going to call this carbon number 1 again, so usually what you do when you draw it, whatever your biggest, bulkiest substituent is, you just put, I usually just draw it here in this top corner, and I make it equatorial because it's going to be the most stable position. So since this is down, this one must be in the up position, right? So when we come here, we have to draw our methyl up because the hydrogen would be in the down position. So these are cis to each other because they're both in the down position. These are trans because one methyl's in the down position and one's in the up position. So the question might be, which of these, which of the structures is more stable?
Of those two?
Yeah.
Oh, okay.
And you would say the cis because
They're
yeah, they're both in the equatorial position.